Okay, welcome to 5 Mathtastic Minutes on the topic of nailing the nth term. Now, sequences is a topic that comes up very often on both the higher and the foundation papers. So we're going to look quickly at some foolproof methods for solving these questions and getting full marks. Now, sequences, though, we need to know a bit of the terminology. We need to know the key words. So a sequence is a succession of numbers that follow a given rule. That basically means that it's a set of numbers that either go up in or go down by a certain number every time. So if you were to look at this sequence below, this one goes 2, 5, 8, 11, 14, 17, 20, 23. So this particular sequence is increasing by 3 each time. And each number in the sequence is called a term. So the first term in this sequence is 2, the second term is 5, third term is 8, etc., etc. The sixth term is 20. Now we also, when we're looking at sequences, we have what's called the nth term. Now basically this means n is describing the term's position in the sequence. So for example, if I said that n equals 8, I would be looking for the 8th term in the particular sequence. If I said n equals 100, I would be looking for the 100th term in the sequence. Now, knowing these keywords helps us when we come to actually answering exam-style questions. So, an exam-style question would be along the lines of, here are the first 4 terms of an arithmetic sequence. What is the next term of this sequence? Well, we can very quickly see that here we have 5, and to get to 9, we need to add 4. To get to 13, we need to add 4. To get to 17, we need to plus 4. So to get to the next term, we just need to plus 4, which gives us an answer of 21. So put it on our answer line, 21. Now this part here, write down an expression in terms of n for the nth term of the sequence. So we're basically trying to find a rule that will allow us to work out any term in that sequence. And the way to do it is this, same way every time. As we've just done here, we find the difference between each term. And here we are adding 4 each time. So we take down a 4 and we put it in front of the letter n. Okay, very simple. We find the difference between the terms and we put that number in front of the letter n. Then what we do is we think, right, what would I have to do to go back to my 0 term, to the term before the first term? So if I'm adding 4 every time, to go back I need to subtract 4. And what would if I took away 4 from 5? I would get 1, a positive 1, and I need to add that to my expression, so my answer is 4n plus 1. Now that rule will give me any term in that sequence. For example, 17 here is the 4th term, and if I were to replace n with the number 4, I would have 4 times 4, which is 16, plus 1 gives me 17. And we're going to apply the same rule every single time. Now, for example, on this question here, we would be looking at, let's quickly get down to the next question, we would be looking at, again, this time the nth term of the sequence is given by, they've actually given us the rule here, work out the first 2 terms of the number sequence. Well, if we want to work out the first 2 terms, the first 2 terms are going to be where n equals 1 and where n equals 2. So all we have to do is replace n in the expression with 1. So 3 times 1 is 3, plus 1 is 4. And then we replace n with 2. So we do 3 times 2 is 6, plus 1 is 7. That gives us our answer. And again, this time we're asked in terms of n, an expression for the nth term in this number sequence. Again, what do we do to find our nth term? We find the difference between them. So in this case, again, it's plus 4, plus 4, plus 4. So the number, we put 4 in front of the letter n. And again, what do? We go think about, right, what would this number here be if we went back one? Well, to get to go up the sequence we add 4, so to go back down the sequence we would subtract 4, and 1 minus 4 is minus 3, negative 3, so that is what we would put on here. And again, that is a very simple 2 or 3 marks.